Hello, I hope everybody's doing well. I'm going to dive right into this lesson. This is going to be the first part of two-part video, and it's related to vector addition. About 4 to 5 weeks ago, we discussed the difference between vectors and scalars, and when we first introduced vectors, we came up with this definition that a vector is a measurement with a direction. Now remember, you will hear the word magnitude quite a bit, and magnitude is just a synonym for the word measurement. So anytime I hear the word magnitude, I think of the word measurement. Here are some examples of vectors. Displacement is a vector. It tells you how far you've moved compared to where you originally were. Velocity is a vector. Acceleration with direction is a vector. Force is a vector. Let's jump into some examples of adding vectors now. So if I have two vectors, vector A and vector A is pointing to the right and vector B is pointing to the right, and I'm asked to add the two vectors, I have to follow the rules of vector addition. The first rule of vector addition is that you can pick up and move vectors. You cannot change their direction and you cannot change their size, meaning you cannot change their measurement, but you can pick them up and you can reposition them. So what I've done is I picked up vector B and I've placed it in such a way that vector A and B are now touching head to tail, and that's a very important piece of vector addition. Always rearrange them so that they're touching head to tail. This is the head of the vector, this is the tail of the vector. So as you can see, vector A and B are touching head to tail, and this would be the resultant vector. This is the sum of vectors A and B. So if vector A is 4 meters per second and vector B was 2 meters per second, I rearrange them so that they're touching head to tail, and the resultant vector would be pointing towards the right, and its measurement, its magnitude would be 6 meters per second, which is 4 plus 2. So when vectors are pointing in the same direction, it's very simple. You just mathematically add them. Now, vectors are pointing in opposite directions, such as this example. Vector A is pointing towards the right, vector negative B is pointing towards the left, and if somebody asks me to go ahead and add the two vectors, vector A plus negative B, then what I'm going to do is I'm going to follow the same rules as before. I'm going to rearrange the vectors so that they're touching head to tail. So as you can see, vector A's head is touching vector B's tail, and the resultant vector is going to be this one right here, A plus B to the right. So the resultant vector is going to be from the beginning to the end of B. So the beginning of A to the end of B, so that's going to be pointing towards the right, which is this guy. So if you picked up this vector A plus B and placed it right here, that would be the resultant vector of A plus negative B. So this guy is minus B. I'm going to go ahead and put a minus there. So that is A plus negative B. That's the resultant of A plus negative B. That's what it looks like. So if vector A is 4 meters per second and vector B is negative 2 meters per second, I place them head to tail, and the resultant of these two vectors would be 2 meters per second to the right, because that is what's going to be remaining from the beginning of vector A to the end of vector B. So the resultant would be 2 meters per second to the right. So basically, when vectors are in opposite directions to each other, you just simply subtract them. Now, if two vectors are perpendicular to each other, we discussed this in class briefly. You're going to place the vectors head to tail, as I've shown you, and then you can use Pythagorean theorem to find the resultant vector. That's going to be the hypotenuse. So the resultant vector is going to look like this. So for example, if vector A was 4 meters per second and vector B was 2 meters per second, as you can see, I've drawn them here perpendicular to each other where they're touching head to tail. This would be the resultant vector. It would be the square root of A squared plus B squared. So the square root of 4 squared plus 2 squared, which is going to be equal to 4.47 meters per second in this direction. And later on, we'll discuss how to find the direction of a vector by finding the angle theta. If the vector falls on the x or the y axis, it's pretty simple to find the direction. But if it doesn't fall on the x and y axis, then we find the direction by finding the angle theta. We'll talk about that later in the video. Now, I've used the word resultant vector a couple of times, so I just want to mention to you that this is the symbol of a resultant vector. This means the sum of the vectors. So we're going to be using Pythagorean theorem to find the resultant vector. I'm going to pause the video here and I'm going to restart the second video.